Hey everyone, this is Derek, and this video is going to be about linear functions. It's section 2.2, and I'm looking at these notes, and I think it's going to be a pretty long section, so I think I'm going to do a part 1 and a part 2 on this one. So in this first video, I'm going to cover intercepts, and then finding the equation of a line in slope-intercept form. And then if your question involves questions about finding the equation in point-slope form or parallel and perpendicular lines, I think I'm going to put those in the second video. Just because I'm afraid this thing's going to get really long otherwise. So we'll make this part 1, and part 2 will have, like I said, point slope and parallel perpendicular. So look there for those topics. Okay, so for part 1, starting off with intercepts. And we're going to see intercepts in all different versions in this course. So like any kind of an equation can have an intercept. But kind of the key thing with intercepts is if you're looking for an x-intercept, it's going to have the form, some value and 0. So to find any x-intercept, no matter what kind of function we're looking at, we got to let y equal 0, and then that puts us on the x-axis. Likewise, to find a y-intercept, we're going to let x equal 0, which puts us on the y-axis, and then solve for the y. And so that's going to be true whether we're doing linear functions, quadratics, rationals, exponentials, logs, whatever we got coming up. Those two ideas, to find x, let y equal 0 solve, to find y, let x equal 0 solve. We'll see that over and over this quarter. So here it is with linears. And in this, we're going to have equations. We got two forms here for the equation of a line. And this is kind of coming up, but I'll just point them out right now since I have examples of each. This is what's called standard form. So they're going to be a, b, and c are going to be integers, which means not fractions. And then the x and y are on one side. So that's standard form of a line. And then we have slope-intercept, which hopefully you've seen in a previous course. That's that y equals mx plus b, where m is our slope and then b is our y-intercept. And so those are kind of the two versions of this that we're going to see throughout. We'll also pick up point slope in the second video. So for this one, when we're in standard form, finding the x and y intercepts is often a really good way to get something graphed from this form. Not the best way to get something graphed from this form, but pretty good for this one. So here, if I let x equal 0, then I'm going to be solving for y, right? So 4 times 0, that piece would drop out, and I would just have negative 5y equals negative 20. There I can divide the negative 5 over, and I would have y equals positive 4. So as an ordered pair, that would be when x is 0, y is 4. And then to find the other intercept, we're going to let y equal 0, and that'll let us find the x-intercept. So when y is 0, this piece drops out, and I'm left with 4x equals negative 20. Dividing the 4, we get x equals negative 5. And so as an ordered pair, when x is negative 5, y would be 0. And then once I have those 2 points, this would be x is 0, y is 4 would be here, negative 5 is 0, so I'm back here. Then that's graphing using the intercepts, and I got the graph of my line. So that's actually a pretty nice way to get that graphed. And I showed a lot of steps here when I'm doing this for myself, right? I'm just going, okay, when x is 0, this is gone. Negative 5 into negative 20, that would be 4. When y is 0, that's gone 4 times, it'd be negative 5. So you can really kind of shortcut this down, but I'm just kind of trying to show the steps in this first example for these, but that's kind of what I've been doing in my head. So pretty quick way to get them graphed from here. For this, that's totally not how I get a graph. This I would start at negative 8 and then use my slope, which would actually go this way. But this question is specifically asking us to find x and y intercepts, so let me show that. So if I let x equals 0 here, I would have y equals negative 3 times 0 minus 8. And you can see that that term's always going to drop out when an x is 0. And so that is why this value on the end is going to be the y-intercept. So when x is 0, y is negative 8. We don't even need to do that math if we're in slope-intercept form because y-intercept's right there. Okay, so then let's find the x-intercept. So for that, we're going to let y equals 0. So we'll have 0 equals negative 3x minus 8. Add the 8 over, so that gives me 8 equals negative 3x. And then divide both sides by negative 3. And that gets us x is negative 8/3. So that would be negative 8/3 when y was 0. So those are my x and y intercepts for that one. Okay, number 2, Marcos purchased a top-off card for his prepaid cell phone. His remaining balance, B, can be modeled by the equation B equals 45 minus 0.15 n, where n is the number of minutes he's talked since purchasing the card. A, how much was on the card when he purchased it, and which intercept is this? So let me write this equation a little bit larger up here so I can point at it. So B equals 45 minus 0.15 n. So n was the number of minutes he talks, and then B is the balance, how much money he still has left on the card. So how much money was on the card when he purchased it? Okay, so when he purchased it, he hadn't talked at all, right? So that'd be 0 for the n, and that would mean B was 45. And so which intercept? That would be the B intercept. In part B, how many minutes will he have talked when he runs out of money? Which intercept is this? So when he runs out of money, that means the balance will be 0. So that means we're finding the n intercept this time, the number of minutes. And that's how many minutes? That makes sense. That's the n. And then we'll just add that over. And so that gets us positive on this side. And now divide out the 0.15. And then I'll sneak over this way. N equals 300. And so that would be the n-intercept, which is the number of minutes he's talked since purchasing the card. So that means he could talk for 300 minutes, right, before he runs out of money. And then C, what is the slope of this equation? And then what are the units of the slope? So the slope is the one that's with the variable. So the slope is negative 0.15, oops, with a 1 there. And then the way I think of this is, remember, slope is change in y over change in x. So in this case, with the letters they're using, it would be change in B, the change in balance per change in number of minutes he talked. And so this is how his money is going to change. So this is dollars per change in 1 minute. So for each minute he talks, his balance is gonna go down 15 cents or $0.15. Okay, so this one has a fair bit of writing to it, and this is sort of how the question will look on the computer screen. So I'm just trying to give you an idea as to kind of what you'll encounter when you see the actual questions. So Diana graduated and wants to spend time off in Sacramento. Before graduating, she saved $8,450 for this trip and plans to spend $650 per week for food, rent, and activities. If she graphs her amount A of savings in dollars, so A's how much money she has, and time T in weeks since the trip started. So now, which variable would represent the dependent variable and which would represent the independent? So remember we saw back in chapter 1, independent variable, that's kind of like what we would normally think of as y, and then the independent variable is what we would normally think of as x. It's the input is the independent, the output or dependent. And so she is wanting to find, if she graphs her amount A of savings in dollars and the time and weeks since the trip started, feels like she's going to have this much money, and we're going to figure out how many weeks, right, she can live off of her money. So I think T is going to be our independent variable. We're going to want to put in time, and then we're going to see how much money she has left. And so this will be like a check the box for which one. So it'd be, T would be independent, and the amount of money will depend on how much time has passed. You could write it the other way, but it doesn't make sense, at least to me. B, on which axis would the variables be most commonly shown? Okay, so that's what we're just kind of saying there. So the independent variable is generally shown on the horizontal, and then the dependent is generally shown on the vertical. And so A would be vertical, and then T would be horizontal. So that'd be that one. C, give the coordinates of the vertical intercept. So if in our vertical intercept, that was this amount A, and so that would be how much money is she starting with. So that would be right here. At time 0, she had saved $8,450. So that would be our vertical intercept. And then give the coordinates of the horizontal intercept. Okay, so the horizontal intercept, that means she's going to have no money left, right? Because our amount will be 0. And she is starting with $8,450. And then each week she's intending to spend $650. And that would be T. And so now, if you're starting with this much, and this is how much she's going to spend each week, now I can solve for that T and figure out how long until she's out of money. So I'll bring this over. And then divide over the 650. It looks like T comes out to 13. And so that would be 13, 0. And so then part E on this question is, what does the vertical intercept represent? And so again, if we're kind of thinking of this graph, the vertical intercept would be how much money she had at the start of the trip. So that was how much she had saved. And then what does a horizontal intercept represent? Remember, that's when the money, her amount is 0. So this is how long 13 weeks is when she's going to run out of money. Okay, so then the second topic in this video is going to be finding the equation of line and slope intercept form. And so that's where we're going to use this y equals mx plus b. And so again, m was our slope, and then b is going to be the y-intercept, which we've seen a bunch of times, but now we're just doing it a bit more formally, given a point and a slope. So I'll be using this a bunch for these next examples. Okay, so 4 is find the equation of a line with the slope of 3 passing through the point 8 and 42. Write your equation in the form of, that should say y equals mx plus b right there. Okay, we know m is 3, and we know the point is 8 and 42. And so what that is an xy. That's an ordered pair that's going to satisfy this equation. And so I'm going to just put the 42 in for the y, and then mx, so m is 3, x is 8. And what that does is gives me everything but b. So once I have a point, I can use that point with the slope to solve for the y-intercept. So 42 equals, I'll be 24 plus b, and we'll slide the 24 over. And that is going to be 18. So writing down our answer, we got y equals m, which was 3, x, and then plus 18. So notice the x and the y, those stay variables, right? The two things we need to find when we're finding our equation is the slope and the y-intercept. Sometimes they will just give you the slope like they did in this one, and then sometimes you'll have to kind of work to get the slope, which will be the next example. All right, number 5, an elk population in North Cascades grew from 150 in 2015 to 198 in 2019. Let T be the number of years after 2015. So what that means is in 2015, we're letting T equal 0. And then P is going to be the population of elk. So write the ordered pair T comma P from these data above. So 150 is going to be my population. So a couple of things going on. One, we got to shift T. 2, they wrote the points backwards. So T is supposed to go first, and 2015 is now, we're calling that 0. So that first point is going to be 0, is 2015, and the population that goes with that is 150. So hopefully that makes sense, that we're letting 2015 be times 0, and at that time the population is this many elk. And then the next time we're given is 2019, which is 4 years later, so we're going to let that be 4. And what it lets us do is not put giant numbers into the formula we're making. We get to get a little bit cleaner numbers to work with. And at that time, the population is 198. So that would be our ordered pair for this data. Find the change in population. So remember, delta means do P2 minus P1. So it's changing. So change in population, delta P is going to be 198 minus 150, which would be, the change in population was 48. Okay, so then to find delta T, we're going to go 4 minus 0, so delta T will be 4. And then to find the rate of growth, that's our slope, so change in population over change in time. So delta P, delta T will equal 48 over 4 or 12. How much did the herd grow each year? What are the units? So the herd was growing at 12 elk per year. And that's because, remember, this is population and this was time. And then F is write a linear model for P in terms of T. And remember back here we set 2015 as T equals 0. So that means we already know our y-intercept, so that makes this pretty easy. P will be 12 times each year plus the 150 that there were in 2015. Okay, number 6, the cost to produce 100 t-shirts is $450, while the cost to produce 250 t-shirts is $975. Write an equation to model the situation using N for the number of t-shirts and C for cost. So, go 100 t-shirts went with $450, and 250 t-shirts went with $975. And so, and notice, so the number of t-shirts, that is N, and C is like my Y, it's my output variable, that's the cost. So we'll find our slope and we'll use one of these points and then we'll use that to get our equation. So getting slope, we're gonna have M equals 975 minus 450 and then 250 minus the 100. And so that gets us 5 1/4 divided by 150, which will come out to 3.5. And then we have, so C is our Y, so C equals M, and then N is our X plus B. So I'll just grab this point since the numbers will look easier, and then our slope, and use that to find our intercept. So 450, slope of 3.5, N is 100 for that 450. And so that would move the decimal 2 places. So this is going to be 450 equals 350 plus B. And then subtracting that over, we get B equals 100. So then my equation is going to be cost equals 3.5 times N, number of shirts, plus 100. Okay, so part B, what is the cost to produce 0 shirts? This is called the fixed cost. So there's 2 kinds of costs often in these sorts of problems. There's a fixed cost and a variable cost. So fixed cost is something like rent, where that doesn't change. You pay that whether you made anything or not. And then variable cost will be how much it costs per unit to make the item. So in this case, they're asking what was the cost to produce 0 shirts. So N is 0, so you can see the cost to be $100. And that's going back to the idea of intercepts. That's our y-intercept, so that's our fixed cost. And what is the rate of the change? What is the rate of change for the function? So that was 3.5, but then what are the units? And this is the variable cost. So remember, it's delta C over delta N. So it's the, N. So it's the change in how much it costs per unit. So this is the change in cost, that would be dollars. So $3.50 per 1 unit is what the units would be. So dollars per unit. So in other words, it costs them $100 to set up the operation, and then $3.50 to make each shirt thereafter.